So Descartes' rule of signs is to help us narrow down from all those possible rational roots to what ones will actually be possible. And the conjugate root theorem helps us write equations of polynomials based upon some of the roots. We've already done some of this. We did some of this on the last test, where I gave you some of the rational roots. Today we're going to be looking at some irrational roots, or some imaginary roots, and completing those. Okay. We are going to start with Descartes' rule of signs, and you'll hear me say that multiple different ways, because I'm really not for certain how you say the guy's name. And with this is a way for us to determine how many possible positive real zeros and negative real zeros we have. And so I'm going to go through two different examples, and you're going to want your calculator out for this. So problem 1, we have f of x is equal to 2x to the 5th plus 10x to the 4th plus 7x cubed plus 35x squared minus 4x minus 20. We will use this to help us determine how many positive real roots. So without changing anything, we are going to count how many times did we change from positive to negative, going from one term to the next. These have to be in order from greatest to least of exponents. So they have to be in standard form. So we're positive all the way until here, right? And so we change once here. Do we change after that? Is everybody else negative? So there's only one change. So possible positive real zeros is 1. So out of our list of terms, on this one, you might actually go through and see how many zeros you can come up with versus using synthetic division and see how many times I can plug them in and it work. I know that there's only going to be one of those that's going to be positive. The rest of them are going to be negative. There is a possibility of having up to 5 because my highest power is 5. So that means the other 4 are negative or imaginary. Okay, let's do the next one. The next set idea on this. To find your negative, what you do is you are going to plug in a negative x. So 2 times negative x to the 5th. So if you don't know what negative 1 to the 5th is that going to be positive or negative? Negative. So that means that section is going to be negative 2x to the 5th. And we're going to kind of talk through each one of these as we hit it. So 10, and we're plugging in a negative x to each one of these where there was an x before. So if I'm taking negative x and I'm raising it to the 4th. So negative 1 times negative 1 times negative 1 times negative 1 is positive 1. So it'll be positive. If I'm plugging in a negative x on this next one, it's negative x cubed. That means I have negative x times negative x times negative x. That means we have 3. So that's going to make it negative. So if it makes it negative, I'm going to change the sign in front that plus sign to a negative sign, so negative 7x cubed. Plus 35x, negative x squared. Is that going to be positive or negative?
Plus sign.
Plus sign, because negative x is positive. And then minus 4 times negative x, it's going to be positive 4x. And then the last thing is at minus 20. So did my number of sign changes change when I plug in a negative x? Yes. It will either increase or decrease. So let's look at it. So I'm negative. Then I change to positive. Then I change back to negative. Then I change back to positive. Then I change, I have to stay positive for another one, and then become negative. So let's count how many sign changes did I have. I had 1, 2, 3, 4. So I had 4 sign changes. So my possible negative real zeros is 4. Now, it's not only 4. We can actually have it to where it's 4 or 2 or 0. So you're going to subtract 2 each time, and it's always subtract 2. So the reason we didn't have to do it the first time, if I subtract 2 from 1, do I end up with a positive number? And there's no way to have a negative number of possible positive roots.
Why do we subtract 2?
Because the other ones could be imaginary. So we could have a possibility of 4, 2, or 0 imaginary roots as well. Complex roots. And it will be that way every single time. We're going to do one more of these because I know these are a little bit tricky. And so f of x is equal to 10x to the 5th plus 4x to the 4th minus 65 x cubed minus 26 x squared plus 105 x plus 42. So, for it being just the first time at the end, that's the ones that are going to be for the positive. Let's go through and figure out our sign changes. I'm positive, then I change to negative, then I change to positive. So how many sign changes do I have altogether?
2.
1, 2. So possible positive real zeros are 2. Can I subtract 2 from that?
Yes.
So 2 or 0. And the reason it's always subtracting 2 is because of the conjugate root theorem, which we're going to talk about here in a second. Anytime you have anything that's imaginary, there's always 2 of them.
So on the first one, when we got positive 1, you still subtract 2 from it?
Can you get a positive number if you subtract 2 from 1?
Oh, so you have to get a positive.
They have to be, because you have to be a countable number.
Okay.
You can count to 0, you can count to 1, you can count to 2. And so that's the reason we didn't on the first one. So now we're going to plug in a negative. So f of negative x. So we have 10 times negative x to the 5th plus 4 times negative x to the fourth minus 65 times negative x cubed minus 26 times negative x squared plus 105 times negative x plus 42. Do these numbers really matter for us at this point? What numbers they choose to put in there? The 105s and all the big numbers in there, they look scary. They don't really affect us in any way. It's just the signs that are what we're looking at. So if I am taking a negative and raising it to the fifth power, is it going to be positive or negative?
Negative.
So negative 10x to the fifth. If I'm negative and I'm raising it to the fourth power, positive or negative?
Positive.
So positive 4x to the fourth. A negative and I'm raising it to the third power, negative or positive?
Positive.
Negative. Negative times negative times negative is negative. So now, this is going to be negative here, and so that's going to make the 65 positive. And that may be where you're going. You may have been taking us to the next step. So we have a negative squared. And so that's going to be positive in there, so that's going to make the whole thing not change its sign. And then that's going to be a negative 105x plus 42. So let's now go back and count our sign changes. So we're negative for the first one, and then I'm positive for the next two, negative for the next two, and positive for the last one. So how many sign changes did I have?
3.
3. 1, 2, 3. So my possible negative real zeros are 3 or 1. Is that making sense how the Descartes rule of signs? And like I said, this is helping us. When you have a high power like this, we know that there's 5 possible roots because there's 5, the fifth power is what we're raised to. And so this is helping you narrow down which ones to try. It really is nice whenever one of these ends up being no changes, and then that means you don't have to worry about plugging any negatives in. And that does happen, or no positives in. And that does happen. Okay. Now let's talk about the conjugate root theorem. The conjugate root theorem says, first off, let's figure out what a conjugate is. So a conjugate. If I have 5i, its conjugate is negative 5i. If I have the square root of 2, its conjugate is negative square root of 2.
So it's like
The opposite. Now, if I have 4 plus 5i, then it's going to be 4 minus 5i. These are conjugates. If I have 7 minus square root of 2, its conjugate is 7 plus the square root of 2.
Why would you not change the sign of 7?
You always change it just in front of your square root or imaginary number. It's just the way it works. But it always connects to whatever's the square root or imaginary. But the conjugate root theorem says that anytime you have a polynomial, you can't just have one of these. You have to have both of them every single time as factors, or as your rational roots. So if I tell you that you have your possible, or excuse me, not your possible, your zeros are -3 and 2i, what is one of the zeros that's not listed that we need to fill in?
It would be +3.
So we have right now 2 of them. What do I know the third one has to be? -2i. There has to be that pair to go with it. So anytime you have an imaginary, there has to be a pair to go with it. And so we're going to do it just like we did last chapter. You're going to set each of these equal to 0. So we're going to set x equals, or not equal to 0, equal to x, and then we'll set it equal to 0. So how do I get this set equal to 0?
Add 3.
Add 3. So x plus 3. Then for the next one, we have x equals 2i. So we're going to subtract 2i. So x minus 2i. And then for the last one, we have x equals -2i. So add 2i. And so x plus 2i equals 0. So when we go back to actually write our equation, f of x is equal to x plus 3, x minus 2i, x plus 2i. If you don't have to, you can leave it factored, you stop here.
That's factored.
This is factored. If it wants it in standard form, that means you have to multiply it out. And so we are going to, what I recommend always doing is starting with this section here, because they are the exact same with opposite signs. And so that means that will, and this is always what's going to happen with these, when it's just a number like 2i or -2i. It's going to square the first, so x squared, minus 4i squared. What's I squared?
I. Oh, wait.
I times I is
-I?
-1. So this is x plus 3 times x squared plus 4. And then you use FOIL or the box to multiply that again. So x cubed plus 3x squared plus 4x plus 12. And all I'm doing is multiplying them, making sure everybody hits everybody else. And so I multiplied the x times each part, the 3 times each part on the other parenthesis. And that's it in standard form. This next one, I don't want to spend the whole time going through and multiplying it again, so I'm just going to help you get set up on it. And we have our x is equal to 3 plus I and -1. So what's the one that's not written? What's my missing one?
X minus I? Or X?
X minus I. Or 3 minus I.
Yeah.
Excuse me. So you would say x equals 3 plus I. X equals -1. and x equals 3 minus I. And these are a little bit more complicated to multiply together, but just use the boxes. And so we're going to have f of x is equal to, oops, I haven't got it equal to 0, have I? So if I need to get this equal to 0, doing the first one first, I need to subtract 3 and subtract I from both sides. So x minus 3 minus I equals 0. I need to add 1 to both sides. X plus 1 equals 0. And I need to subtract 3 and add I. So x minus 3 minus, or plus I equals 0. And so f of x is equal to x plus 1, x minus 3 minus I, x minus 3 plus I. And that's it in factored form.